Hi everyone, my name is Vlad, and today we will be solving the problem how to reverse a list in Python in place without using built-in reverse method. Here we have an array of integers a, 1, 3, 6, 8, 2. Let's put indices under the integers 0, 1, 2, 3, and 4. So how can we solve this problem? We need to reverse this array and we need to do it in place. So we cannot create a new array, we need to reuse an existing one. Let's loop over this list from the left and from the right, and at each step, at each iteration of our loop, we will be swapping elements on both sides. Let's create two variables to track our movements. In variable I, that's going to be our left edge. It will start from the index of the first element, so it's 0. And variable j, that will start from the index of the last element, so it's 4. And we will continue doing that until we reach the middle of the list. In other words, until I is less than j. Okay, so let's try the first iteration. Let's check our condition. 0 less than 4, it is true, so we can proceed. Let's draw our array A, and at this point we will be swapping element at index 0 and element at index 4. So we'll be swapping 1 and 2. So instead of 1 we will have 2, and instead of 2 we will have 1. And the other elements stay the same. So 3, 6, 8. So that's how our list looks like after the first iteration. Okay, let's move to the next step. We will be increasing I by 1. So I will be equal 0 plus 1, 1. And we will be decreasing j by 1. So j will be equal 4 minus 1, 3. Let's check our condition. 1 less than 3. It is true, so we can proceed. Let's redraw our array. And at this step, we will be swapping elements at indices 1 and 3. So these two elements. So let's write 2, that stays the same. And then instead of 3, we will have 8. And instead of 8, we will have 3. And the rest stays the same. So it's 6 and 1. So that's how our list looks like after the second iteration. Let's put indices. Okay. Now let's move on to the next one. So we're increasing I by 1, so 1 plus 1 equals 2. And we're decreasing j by 1, so j will be equal 3 minus 1, 2. Let's check our condition. 2 less than 2. And we can see it is actually false, because 2 equals 2. It means we stop here. And also it means that this is our answer. Now let's look at time and space complexity of this algorithm. So what about time? If we say that n is the length of our array, then as you can see, we looked from the left and we looked from the right, and at each of those iterations we went half length of the array. So we did n divided by 2 steps. So in other words, in terms of big O, we did big O of n divided by 2 plus n divided by 2 steps. In other words, we did big O of n steps. And in other words, our time complexity is linear. What about space? We didn't create a new list. We've used some temporary variables, but it doesn't change our space complexity. So, as a matter of fact, our space complexity is big O of 1, and it is constant. And it means we satisfy the requirement of the problem to do it in place. Now, let's write some code. Here we have an array of integers a, 1, 3, 6, 8, 2. Let's write a function reverse that will take this array as an argument and reverse it in place. Here we have our function reverse. As you remember, we need to track our movement from the left and from the right. On the left we'll have variable I that will be equal to the index of the first element, and that's 0. And on the right we'll have variable j that will be equal to the element of the last index, and that's length of our array a minus 1. And we will keep swapping the elements until we reach the middle. So while I is less than j, we will swap element at index I with element at index j. So a from I will be equal a from j, and a from j will be equal a from I. Now we just need to increase I by 1 and decrease j by 1. Let's test our function. We'll print our array before the reversal. We'll reverse our array, and we'll print our array after the reversal. Now let's run the code. And as you can see, here we have our array before the reversal, and here we have our reversed version of this array. Thank you for watching this video. If you enjoyed it, please give it a thumbs up. If you have any ideas or suggestions, please post it in the comment section down below. Thank you, and I'll see you in the next one.